Hello everyone. Plan for this recording is to look at simplifying radicals. We have some square roots, some cube roots, some fractions, etc. Throw some variables in there. So simplifying basically all types of radicals. I don't go any higher in cube roots, although we could do fourth roots and so on, but sticking with cube roots and square roots for this video. So, looking at simplifying radicals. Before I do something like square root of 72, let's go back to something easy. Square root of 25. What number times itself gives me 25? 5. Cube root of 27. What number times itself 3 times gives me 27? 3, because 3 times 3 times 3 is equal to 27. Now, what if the number we're looking at inside the radical, by the way, a radical is a square root, a cube root, a fourth root. This thing right here is called my radical. So what if we have a radical, a number inside there, that is not a perfect square? The square root of 72. What number times itself will give me 72? There isn't one. That's a whole number. So the question then is, write this in simplified radical form. Can I reduce that 72? And the question I have to ask myself is there a perfect square that goes into 72 that I can factor out? So if I think about my perfect squares, 1 squared is 1, which I'm not really going to use, but 2 squared is 4, 3 squared is 9, 4 squared is 16, and then we get 25, and so on. That's far enough right now. Is there one of those perfect squares, numbers that have a square root that's a whole number? Are there any of those perfect squares that go into 72? Now I can do it 2 ways. I'll do it the long way and I'll do it the short way. Well, the first thing I notice, 9 goes into 72. So I can break 72 into 9 and 8. What is the square root of 9? 3. Next question. Can I reduce 8 down any further? It's not a perfect square, but does one of those perfect squares go into 8? Sure. I can break 8 down into 4 times 2. Square root of 4 is 2. So this becomes 3 times 2, which is 6. Square root of 2. That there is 2, and that it means multiplication. 3 touching the square root of 4 means 3 times the square root of 4, which gives me 6. Square root of 2 is not a whole number, so I leave it alone. When you simplify a radical, the goal is not to get it down to a decimal. The goal is to leave it in simplified exact radical form. The square root of 2 is an exact number. I didn't have to cut it off anywhere. I didn't have to take the decimal that was on my calculator and stop it at hundreds or thousands or even 10,000. It's an exact number, square root of 2. All right. So I did it using 2 different steps, but I could have, let me get rid of this. We know that's my answer. I could have broken 72 down right away into the square root of 36 times 2, because 36 times 2 is 72. And I know the square root of 36 is 6, and the square root of 2 is just 2. And I get the same answer whether I did it in 1 step or 2 steps. So don't stall out saying, well, I don't know the biggest. Okay, just pick one. Find something that's a perfect square that goes into the number, break it down, and then ask yourself the question, is what's left inside factorable? Or can I take a perfect square out of it also? All right. At any time during the video when you think you've got it, hit pause and try the next problem, and then come back and join me, and I will continue on through the solution. Okay, square root of 45. Give it a try if you can. Okay, perfect square that goes into 45. 9 and 5. And you don't have to put those little marks there. I just kind of do to show that I'm separating it into 2 parts. So I could write this as a square root of 9, square root of 5, however you want to write it. Next step. What is the square root of 9? 3. What is the square root of 5? I don't know. Some decimal. 2 point something. So I leave it alone. 3 square roots of 5. X cubed. Hit pause. Try to simplify the square root of x cubed. Okay, same question. What perfect square goes into x cubed? Well, if I think about it, perfect square. X squared is a perfect square because x times x equals x cubed. This is a tricky one. Does x squared go into x cubed? Yes. What do I mean when I say go into? Does it divide evenly into it? Or can I take x squared and multiply it by something and get x cubed? Yeah, I can change x squared into x squared times x. Why? Because x squared times x means I have 3 x's being multiplied together, which is what x cubed means. I add my exponents to get when I multiply. Okay? What is the square root of x squared? X. What is the square root of x? I don't know. So I've got it. X times the square root of x. All right, so there is some simplifying basic radicals. And I have some more practice problems here in a second for you to try. All right, what is simplifying a cubic going to look like? Well, now I don't want to look at perfect squares, so I'll get rid of this mess. I now want to look at perfect cubes. Same question applies. How do I break this down now into perfect cubes? So what perfect cubed goes into 81? So my perfect cubes, 1 times 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. 3 times 3 is 9 times 3 is 27. 4 times 4 is 16. Times 4 is 64. 5 times 5 is 25. Times 5 is 125. And we can keep going, but we'll stop there. Which one of those numbers goes into 81? 27 does. I can break this 81 down into the cube root of 27 times the cube root of 3. What is the cube root of 27? Well, it's 3 times 3 is 9 times 3 is 27, so it's 3. What is the cube root of 3? I don't know. Some decimal, so I leave it alone. All right, try 48. What's the cube root of 48 broken down into? All right, perfect cube that goes into 48. 8. 8 times 6 equals 48. What is the cube root of 8? It's 2, because 2 times 2 is 4, times 2 is 8. What is the cube root of 6? Some decimal, so leave it alone. All right, your turn. Y to the 5th. Try it. What perfect cube goes into y to the 5th? Y cubed is a perfect cube because y times y times y is y cubed. So what do I have to multiply y cubed times to get y to the 5th power? Well, I used up 3 y's. I now need 2 more because when I multiply, I add the exponents. So y to the 3rd times y to the 2nd gives me y to the 5th. And y to the 3rd cube rooted is y. And the cube root of y squared, I don't know. So I leave it inside. Or it doesn't come out to be a nice whole number. Okay. Now, let's put it all together. Put some numbers and some variables. Give you a second to practice. Try that guy. Simplify the 50 first, then simplify the x cubed, and then put your answer into a single term. 50. What perfect square goes into 50? 25. What perfect square goes into x cubed? Notice, I didn't say this at the beginning, but notice if it's a square root, you don't need to put the 2 out here, the index. You don't need that. However, if it's a perfect cube, a cube root or something higher, you do need to put that number there. If no number is written, it's an implied 2. Okay. What perfect square goes into x cubed? X squared. So I can write that as x squared times x. Go through those and evaluate the perfect squares. So I know the square root of 25. I know the square root of x squared. I don't know the square root of 2, or it's not a whole number anyways. And x, square root of x is just the square root of x. Yeah, I'm probably saying that wrong. It's not that you don't know the square root of 2, because it's 1 point something, and I can get a calculator out and I can know it. That's not the point. The point is, it's not a whole number. Okay? All right. There's my answer to that one. Can I simplify 2x down anymore? Nope. So we're done. All right, try the next one. 98. 98 is the square root of 49 times the square root of 2. X to the fifth is x to the fourth times x. Y to the fourth is y to the fourth. Y to the fourth is a perfect square. Do you notice, or beginning to notice, that your perfect squares will be even numbers? Okay. Next step, 49, perfect square, or square root is 7. What two terms multiplied together will give me x to the fourth? X squared times x squared, right? Because when I multiply like bases, I add the exponents. And so I get x squared. Square root of 2 is not a whole number. Square root of y to the fourth. Whoops, sorry. Let me get rid of this. Let's do that one first. That was too much. Y to the fourth is y squared times, sorry, trying to talk and write at the same time. There we go. Y to the fourth square rooted is y squared. So I've done this one, I've done this one, I've done that one. What is left inside? The square root of 2 and the square root of x. Notice, shortcut, when I'm taking the square root of a term with a variable with an exponent. Let's say take the square root of x to the 10th power. I simply divide the exponent by 2. Why? Because x to the fifth times x to the fifth simply says add those two exponents together, and I get x to the 10th. So I want to know what two numbers that are the same will be added together to give me 10. When you're thinking about exponents, you are dividing by 2. When I'm thinking about square rooting, I am not dividing by 2. If I take the square root of 25, I want to know what two numbers will multiply together to give me that. But when I'm talking about exponents and multiplying like bases, you add the exponents. Then I need to add two numbers that are the same, so I simply divide the exponent by 2. All right, use that logic. Help you with that last one on that line up there. 48. What perfect square goes into 48? Well, I can make that a 16 times 3. X to the fourth we just said was a perfect square. Y to the 9th, remember it has to be even, so y to the 8th would be the first even number less than 9. And what's left over? 1y. Y to the 8th times y to the first is y to the 9th, because we add the exponent. Did you catch how I said that? Looking at y to the 9th, I asked myself the question, what even number is right below the 9? That'd be an 8. Okay. Square root of 16 is 4. If you need to do that, mark it off so you know you've used it. Square root of x to the fourth is x squared, because x squared times x squared is x to the fourth. The square root of y to the 8th is y to the fourth, because I simply divide it by 2, because y to the fourth times y to the fourth is y to the 8th. What's left inside? I did nothing with the 3, because it's a decimal answer. I did nothing with the y, because it's not a perfect square. All right, try cube. What's the cube root of that mess? Give it a try. What perfect cube goes into 32? My perfect cubes are 1, 8, etc. Well, 8 goes into it 4 times. Now, if the square root of x to the fifth was something that's multiple of 2, meaning an even number, then a perfect cube would be a multiple of 3, meaning like 3, 6, 9, 12. So what multiple of 3 is just below 5? 3. Like that. Got too close. I'm going to slide it over a little bit here. X to the third cube rooted. Now what times x cubed gives me x to the fifth? Simply subtract the 3 out and I get 2 more left. And y to the seventh. What multiple of 3 is right below 7? Y to the sixth. And what's left? Another y. All right, evaluate the ones that are perfect cubes. Cube root of 8, 2. Cube root of x cubed, x. Cube root of y to the sixth. Now we're dividing by 3. Whoops. And I get y squared. Why is y squared cubed? How do I know that y squared cubed is y to the sixth? Because y squared cubed means take y squared times y squared times y squared. And when you multiply like bases, you add the exponents. Add them correctly. Sorry. So I get y to the sixth. So another little shortcut is if you're taking cube roots and you have variables with exponents, you can simply divide the exponents by 3. All right, what's left inside? Don't forget your cube root symbol. I have a 4, I have an x squared, and I have a y. All right, try the 54 problem. Cube root of 54. That's a perfect cube. About 27. 27 times 2. X cubed is a perfect cube, so I'm going to leave that one alone. Y cubed, so y to the sixth is just below that. What's left over? A y squared. Cube root of 27 is 3. Cube root of x cubed is x. Cube root of y to the sixth is y squared. What is left inside? A 2 and a y squared. Okay? There is simplifying radicals. Now, there are some shortcuts to handle this, but I don't think I want to do them in this recording. We'll talk about them at another time. Okay, but if you can do that, if you can break it down into the chunks, then you've got it. All right, how do I deal with fractions now? Here's a rule to write something in simplified radical form. If something is in simplified radical form as a fraction, it does not have a square root, cube root, etc. called a radical. It doesn't have a radical in the denominator, the bottom. First problem does. So the question then I have to figure out is how do I get rid of the square root on the bottom? I don't need to get rid of the bottom term. I need to get rid of the square root off the bottom term. So how do I make the bottom term a perfect square is really what I'm asking, so that I can take the square root of it and the radical will be gone. So what do I need to multiply by in order to make that a perfect square? How about itself? Square root of 5 times the square root of 5 is the square root of 25, which is itself 5. Well, I can't just multiply something by 5 or by the square root of 5. So what I do to the bottom, I have to do to the top. And now I really have multiplied by 1, right? Because something divided by itself is just 1. And if I multiply anything by 1, I have not changed the number. Okay? I've changed what it looks like, but have not changed the value of the number, because I simply multiplied by 1. Okay, I think that's an important point, but I hope we got it. 3 times the square root of 5 on top. The square root of 5 times the square root of 5 is the square root of 25 on the bottom, which is plain old 5. We have got rid of the square root, or the radical, off the bottom. It is now in simplified radical form. Avoid the temptation to cancel those two 5s. the square root of 5, and the square root of 5 does not simplify. 1 is the square root of 5. It is not the same thing as 5. Okay, your turn. Try the middle one. What does that look like? How do you get rid of that square root off the 7x? Okay, square roots are really pretty simple because you simply multiply by itself. Whatever is down there, just multiply by it. Unless it simplifies and some other things happen, but assuming that's already simplified, just get rid of it by multiplying by itself. So on top, I have 2 square roots of 7x. On bottom, I have the square root of 7x times the square root of 7x, which is the square root of 49x squared, which is 7x. All right, try the next one. Multiply top and bottom by something to make it a perfect square. And again, I can always just do, oh, sorry, let me change this. Notice it's written a little different. When I square root a fraction, I can think of it as the square root of the top divided by the square root of the bottom. Now it looks like the rest of them. So I will multiply top and bottom by the square root of 6y. Sorry, almost ran out of room. So on top, I get the square root of 30y, and the bottom, I get 6y. All right, a couple more. Cube roots. How do you simplify a cube root? Let me do the first one. Because you would think, oh, I'll just do it like the square roots. Well, thought process, yeah, exactly like a square root. But in actuality, it's a little different. I cannot multiply the top and bottom by the cube root of 4. Right? Remember what we just said? Multiply the top and bottom by the bottom, whatever's on bottom, because that'll make it a perfect square. Does multiplying something by itself make it a perfect cube? Is the square root or the cube root of 16 a perfect cube? No. So on bottom, I got the cube root of 16, but that didn't help. So I have to ask myself the question, what perfect cube can I make the 4? Which one of these does a 4 go into? Well, 4 goes into 8. So how do I make a 4 and 8? I multiply by 2. And whatever I do to the bottom, I have to do to the top. Technically, sorry I didn't write this. I had, what number did I have? Cube root of 3, cube root of 4. So technically I have the cube root of 3, cube root of 4, right? I can split that radical to top and bottom. So on top I have the cube root of 6, and the bottom I have the cube root of 8, which is just plain old 2. Question is the same. How do I make the bottom a perfect whatever? Cube root, square root, fourth root, etc. If it's a square root, I can simply multiply it by itself. That is the definition of square. But for a cube root, that doesn't work. I have to ask myself the question, how do I make it a perfect cube? What perfect cube does it go into? And then multiply it by that to make it a perfect cube. All right, try the middle one there. The cube root of 2 over 9y. All right, let me get this guy out of the way because I need more room. So what am I multiplying by? Well, first let's use some correct mathematical notation, and let's split this guy. Now I need to multiply the 9 by something to make it a perfect cube. So how about 3? And I need to multiply the y by something to make it a perfect cube. How about y squared? Y squared times y is y cubed. Whatever I do to the bottom, I do to the top. So on top I get cube root of 6, whoops, sorry, y squared, not y cubed. On bottom, I get the cube root of 27y cubed. So on top, I have still 6y squared, but bottom, I get 3y. I have no problem from going to there, from there to there. Is this simplified? Yeah. You cannot reduce stuff that's inside with stuff that's outside. The 6 and the 3, the y squared and the y do not reduce down. All right. Try this guy. Okay. Again, I'll separate this. Let me get, since I have lots of room here. I'm going to separate this. I'm going to separate this. What perfect cube does 2 go into? 8. How do you make a 2 an 8? You times it by 4. What do I need to multiply x squared by to get x cubed? X. And I do the same to the top as I did to the bottom. On top, I get, excuse me, I get the cube root of 12x. And on bottom, I get 2x. I did what I said you could do, but I won't. Let me show you what I did. 4 times 2 is 8. X squared times x is x cubed. Cube root of 8 is 2. Cube root of x cubed is x. And that gives me that. All right. That is simplifying radicals.